Well, most of us need to be told why, how is a derivative of cos x with respect to dx sine x, negative sine x. How is it that way? So today I'm going to prove it to you. And we're going to use first principles, which states that dy with respect to dx equals the limit change in x tends to 0, f of x plus a small change in x minus f of x all over change in x. This is a really simple thing. Like when we draw graphs, what is a derivative? A derivative is a small change in x and a small change in y. Now what we're trying to do, we're trying to make change in x to be as small as possible. This just means tending to 0, okay? So with this in mind, we'll move on and substitute and come up with our equation for first principles for cos x. So our f of x is cos x. So our f of x plus a small change in x will be wherever there was x, we're going to put x plus a small change in x to obtain cos x plus a small change in x, okay? So from here, since our equation will be quite long, so I'm just going to start from the limit part. And the limit, you should never forget to write it, because if you do, you might not get the right answer. So our f of x plus a small change in x is cos x plus change in x. But wait a minute, there's a way that we can write cos x plus change in x using a trigonometric identity to come up with a part that has a cos x and one that has a cos change in x. How? So before we move to the limit, I'd like us to remember this trigonometric identity, which says a cos x plus change in x is just cos x cos change in x minus. This trigonometric identity is a bit different from how we write the sine x one. Please note that in my other video. So minus sine x sine change in x. So this is the one that we're going to replace the f of x plus change in x part, okay? So it will be cos x cos change in x minus sine x sine change in x, and this is our f of x plus change in x. Now minus our f of x, which is cos x all over change in x. And what do we notice in our numerator? We have a cos x here and we have a cos x here. So what we'll do, we'll put the like terms together. So taking off cos x, we'll have cos change in x minus 1, since there's a minus in front of the cos. Then minus, do not forget this term, sine x sine change in x, and all this is under change in x, and of course do not forget your limit there. From here we're going to remember that the limit as change in x tends to 0 of cos change in x minus 1 all over change in x is 0. How? You'll see it in my next video on limits. And the limit as change in x tends to 0 of sine change in x all over change in x is 1. So this is what we're going to apply. And since, let's come to this equation again. Since we have a limit and we have a minus sign, it's okay for us to divide the limit into this term and this term. And since we also have a denominator of change in x and we have a minus sign, it's okay to put the change in x under this term and change in x under this term as well. So doing all that, we're going to obtain that the limit as change in x tends to 0 of cos x cos change in x minus 1 all over change in x minus the limit as change in x tends to 0 of sine x, sine changing x all over changing x. Voila. And we've just applied what we thought about. Then from there, remember, we are taking the limit as changing x tends to 0. And this term, this is the part that has, I should have used red there. This is the part that has the change in x. And also, this is the part that has the change in x. So those are the parts where the limit is going to apply. So having said that, we're going to obtain cos x limit as changing x tends to 0 of cos changing x minus 1 all over changing x minus sine x limit change in x tends to 0 sine changing x all over changing x. So as I had said before, this part is 0, and there's a video on limits and you'll see why it's 0, and this part is 1. So we'll have cos x being multiplied by 0 minus sine x being multiplied by 1. Any number multiplied by 0 is actually 0, multiplied by 1 just the number itself. So the derivative, we obtain that, the derivative of cos x with respect to dx is negative sine x. Thank you for watching my video.